On.
Hello, folks. This is Jim with Science Talk. I want to kind of share with you some breaking news. Some of you may have heard about what's going on with the Arctic sea ice. And I'll explain what we're looking at here in a moment. But let me give you a little background on what's happening, and then I have an interesting animation to show you, so you kind of see for yourself in real time what's going on. Basically, what's going on is that the thickest part of the sea ice in the Arctic has started breaking up, and it's opening up waters north of Greenland, which is really basically not heard of. There's waters that pretty much stay frozen all the time. A meteorologist described this phenomenon, recorded for the first time this year, as quote unquote scary. Of course, this could prove catastrophic for polar bears, seals, threatening their survival because, taking a loss of habitat. Also, open water, organisms lose heat more readily through the water than to the air, requiring more energy. And that can cause them to basically go hypothermic, and that will kill them. Now, this area off the north coast of Greenland has often been called the last iced area because it was expected to be the last place to remain frozen, given that it had the oldest and thickest ice. Now, sea ice tends to form what we call multi-year. So you have the seawater that freezes, which means that you reject the salt out of the water, so that when it freezes, it's basically fresh water that freezes. You could take sea ice, melt it down, and drink it because there's no salt content in it. That brine, called brine rejection, goes into the water column. Now, you've heard me do videos before where I talk about the density of seawater being controlled, not just by temperature, but by salt content. So that can make surface waters more dense because of this extra salt in there. And sometimes that could sink a little bit in the water column. So you get like a little mini overturn there that can help stir up some nutrients. And later on, in a phenomenon called ice edge effects, you get some productivity around the ice edges. Be that as it may, when you have sea ice that forms, okay, some of it will melt the following spring, some of it persists. And then you get more freezing for the next winter, so that sometimes you can get ice that lasts for several years, and it's called multi-year ice. We have overall, if you look at the other side towards the Bering, the Chukchi Sea, and out that way off the coast of Alaska, there's less and less multi-year sea ice that's found. We're also seeing that the ice is not as thick as it has historically been, does not extend as far south as it has historically been. So there are definitely some changes going on. So this ice off north of Greenland has broken up not just once, but twice this year. And basically it's due to warm winds and heat waves in the northern hemisphere. So I've got some quotes for you from some of the scientists who are looking at this. Professor Peter Wadhams, who heads the Polar Ocean Physics Group at Cambridge University, said the trend would also have serious consequences for wildlife and could prove catastrophic for polar bears and seals, as I mentioned at the outset. The north coast of Greenland, Professor Wadhams continues, with its very steep cliffs, is a denning area for polar bears. They dig holes in the snow and come out in the spring and go hunting. But if the pack ice has moved offshore, they come out of hibernation and they have nowhere to go hunting. They can't swim very far because their energy reserves are down from hibernating. And if this becomes a permanent thing with the ice that they can't get on, they have no place to go to hunt. And even if they could get on ice, if the ice starts being thinner or is not continuous but is isolated ice flows, that makes hunting all the more challenging and difficult for them. Another scientist, Ruth Mottram of the Danish Meteorological Institute, said almost all of the ice to the north of Greenland is quite shattered and broken up and therefore more mobile. What she means by that is that sea surface currents, wind activity can push the ice around more readily. Open water off the north coast of Greenland is unusual, she continues. This area has often been called the last ice area, as it has been suggested that the last perennial sea ice in the Arctic will occur here. The event of this last week suggested actually the last ice area may be further west. If you look at Greenland, basically further west would be towards more centrally off the coast of Greenland. Walt Meyer, who's a senior research scientist at the U.S. National Snow and Ice Data Center, or NSIDC, located in Boulder, Colorado, said the ice there has nowhere else to go, so it piles up. On average, it's over 4 meters thick and can be piled up into ridges 20 meters thick or more. This thick, compacted ice is generally not easily moved around. However, that was not the case this past winter, February, March. And now, the ice is being pushed away from the coast by the winds, and as I'll show you in the animation, also sea current activity as well. And another quote by Thomas Lavergy, who is a scientist at the Norwegian Meteorological Institute, describes satellite pictures of blue water penetrating the white ice as scary. And that's the quote I referenced at the beginning of this segment. Even if the water closes over in a few days, the harm will be done, he said. The thick old sea ice will have been pushed away from the coast to an area where it will melt more easily. So, let's now take a look at this graphic I have here on the screen. And what this shows is the Arctic sea ice volume from the years 1979 to 2018, nearly a 40-year record. Now, what basically appears to be a sine wave is, of course, seasonal variation, where you see there's a line here, 30,000 cubic kilometers, 20, and so on. So up here would be during the depths of winter when ice is at its most volume. And then this would be during the summer months when ice is at its least. So what we see here is basically the very top blue line is from the 1980s. Right? That's this here. And then all the blue lines here, right? And then we go into the 1990s. And what are we seeing? And then as we go down, we get into the 2000s and the 2010s. And this black line with the dot is for 2018. This represents what we have current data for right to here. So what are we seeing overall? When you look at this overall picture, we see that the volume of sea ice has declined quite dramatically over 4 decades. That's what we're seeing. It's not as much wintertime buildup, and therefore there's more that melts come summertime. That's the general picture, the general takeaway I want you to get from looking at this picture. Sea ice volume has decreased. So let's see, there's another. Now, I want to show you this right here. Okay, here's Greenland. Here's Alaska. Okay, Russia. There's the Bering Strait, Chukchi Sea, so on. This is the area, and the animation I'm going to show you, it looks at this region here that I'm showing with the cursor moving. Now this, I guess it's orange. This orange line that you see here is the median ice edge from 1981 to 2010, basically a not quite 30-year time period. And what that median ice edge means is basically median from statistics is you have 50% of the data above that location, 50% of the data below that location. So in other words, this is the median location for the extent of the sea ice. So 50% of the time it will be within, basically during summertime. 50% of the time it will be extending out to here like during the wintertime. So for example, if we looked over here, in wintertime, the ice would be out into the Bering Strait, through Chukchi out into the Bering Strait, and then it melts back come summertime. So that's just kind of give you an orientation here. I just put the cursor, that's the North Pole right there. So we're looking at basically what we got here. So that's about 60 degrees, 66 degrees. So this would be probably 75 degrees latitude. So we're talking about 80 degrees latitude or so right about here. So now on to the animation. And first of all, let me explain what's going on here. You see that there's a bunch of little arrows. Okay. The arrows represent vector quantities. What is a vector? Generally speaking, a vector is a quantity that not only has magnitude, but also has direction. So, for example, if I say, okay, I drove in my vehicle at 55 miles per hour, that is simply, I just gave you only a magnitude. That's only a scalar quantity. And we call that, in this case, speed. But if I said, well, I drove 55 miles per hour due south, now I have imparted a direction. That now becomes a vector quantity. So a vector quantity includes a magnitude or a scalar component plus a direction. So when we look at these arrows here, we have the direction, right? Look at which way the arrows are pointing. The length of the arrows gives you an idea of the magnitude. Longer arrows have larger magnitudes. Shorter arrows have smaller magnitudes, smaller scalar quantities. So let's see. There we go. Now we got to put it in motion. Now what I want, and you see, let me scroll down a little bit. I want you to look at the time frame here. Now this is the European convention, so the middle numbers are the month. So this is the days here. So that's like the 6th of August, 31st of July, and so on. So this is over basically a 2-week period, looks like. Goes up to, actually more of a 1-week period, from the end of July till basically just this past August 6th. So what we're looking at here is the white represents ice. You notice how the arrows change direction due to wind forcing, as we call it, and also sea surface. But now I want you to look at here. Okay, see how it gets more dark blue right in here. You see that? That's what they're talking about, the ice opening up. See? Now the light blue is submerged ice. So there's still ice there, but you have a layer of water over it. The dark blue is no ice there at all. And you can see how the wind is just pushing this away. Usually that didn't happen in the past. It was sufficiently thick, sufficiently steady and solid that, yeah, the wind would blow over, but it didn't go anywhere. Now, you can see how the vectors change, right? It goes from, there's more forcing in a westerly direction, east to west, west to east, and then we have it pushing north to south right here. And when it pushes north to south, that's when we get the opening of basically a channel there. And if you also, stop, okay. I was want to know what the vectors were doing here. And you can also see how it shrinks. You can look overall, the area of ice that's covered, or the ocean, the water that's covered by the ice, the area is shrinking as well. Now, some of that is to be expected as you approach summer months and so on, but this is quite dramatic. I mean, this is a big, big area here. It may not look like much on this animation, but that is quite that's quite a bit. So I wanted to bring this to you. I wanted to show you, give you an idea. This is what we scientists do. We kind of play around with stuff like this. You have a stations recording the data, and you construct this and so forth. So this is breaking news. When this gets written up and published in a peer-reviewed journal, explaining in more detail what's going on, I will be sure to bring that report to you. But until then, we got some interesting stuff going on off the coast of Greenland. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.